Go.
Okay, so I'm here with First Robotics Team 1977. What have you guys been doing with your vision code?
Well, we've been working hard to get our vision code working as smoothly as possible. So we've tried to make a really nice interface for the drivers to use, and one that's pretty much completely automatic. So if we zoom in, well, I guess to start off with actually would be a better thing. The main part of it is what we're doing with the camera, like the most important part. We have a ring of blue LEDs in the front that help illuminate the retroreflective tape. So if we, and the effect is pretty dramatic if you like put the camera behind the camera. Yes.
I'm sorry. I'm sorry.
Be disconnected.
Okay, so while they're getting that back connected, can we look at the interface maybe?
Okay, so basically now that we have our handy dandy blue targets illuminated, we can look at them here on the screen. The first thing you can kind of see if you look closely, we have two targets found here, both drawn, or both have little boxes drawn around them. Pretty easy for the drivers to see, and inside they have a little bit of text that defines their target numbers and distances. We calculate the distance based on the image, distance to the target rather. The idea is that we can calculate the trajectory of the ball that we need in order to shoot. All on the computer. So basically, if a driver wanted to shoot, all they would have to do is find a target, put the mouse over it, the whole target will light up, and then they just have to click on it, and it will begin tracking the target and beginning the shooting sequence. And by tracking the target, we mean, right now this is target number 22, and it's, the vision code is able to continuously locate that same target throughout different frames. So as we move the camera view around, this stays target number 2. The red target stays red, meaning that it's tracking that one right now.
Then it just lost it.
Yeah, occasionally it loses it, but we generally don't have any issues with that, which is pretty awesome.
Okay, you want to tell us about up here in the corner?
Oh yeah, up here in the corner, it basically is just a little bit of debugging code, I suppose. When you begin tracking a target, well, it first tells you the number of targets it's tracking, and then if you're actually aiming at a target, and you can tell because this one's illuminated red, then it will tell you up here, and when it's right in the middle, when the camera's properly positioned, it will stop aiming, meaning the physical robot will stop attempting to rotate our shooter to face the target. So when it's right in the middle, and at this point, if this were on the physical robot, it would actually shoot the ball at this point, or at least aim it vertically and then shoot it. Yes.
Okay, so what else are you using anything special along with this, or?
Well, we found that due to different lighting conditions, we would have to change around our filtering colors quite a bit. We basically have three main filters. We have like the red values for the image, the green, and the blue values. So we have a maximum red value, a minimum blue value, and then a upper and lower bound for the green values. And that's just based off of what we've learned about how the light looks to the camera that's reflected. We also have another special tool that we developed specifically for the use for our vision code. Basically what it does is it allows us to take the current image from the camera and just sample it, and then it'll give us some values that we can plug into our other code, or tracking code rather. So if you just open up the app, you can then find the image and then just click on the parts of the image that we want to recognize, and then on the right side over here, you can see, oh, these are the red values it's finding, these are the green values it's finding, and these are the blue values it's finding. It calculates the mean and standard deviation, so we can find the range of values that are acceptable and err on the side of caution to make sure we aren't missing any targets, which works quite well. We rarely lose our targets at all.
Yeah, and the red lines just sort of floating around are possible candidates that don't form a polygon.
Yeah, the conditions are actually based mostly off of the sample code that they gave us, the sample code WPI gave us. It looks for, using the OpenCV libraries, 4 vertex convex polygons that are within our ranges.
And as you can see, it's we pretty much only find the targets we want to find. It's very low noise.
Yeah, and actually this noise is almost like not enough. In a competition setting, we would probably want even more, just because in the end it's the drivers who do the real targeting, so we can have them make sure to click the right one and we don't not find any targets. So.
Is there anything else you want to show me, or is this...
I think that about sums it up. Thanks for watching.